Phase one has really started, the short time that I've been with phase one, with one or two cameras, and now the breadth and the depth of the product line has increased quite a bit. And so it really comes down to what is the right camera, what is the right lens or combination of such that makes the most business sense for a particular use case. So what I hope for those that stay on and listen to this can gather is, a little more better understanding of who phase one is, the specific products and how they fit with specific use cases, and come away with a better understanding of that. And of course, reaching out to me afterwards via email, phone, text, what have you, to answer any specific questions. I'd be glad to do so. So this particular slide shows an image of our Broomfield office at the Rocky Mountain Municipal Airport. If you ever have a chance to visit, I encourage it. Give me a call. We'll set up a time for you to come in whenever you're comfortable to do so. It's a beautiful office with beautiful people, and we'll make sure that you enjoy your time there. Phase one is typically synonymous with medium format imaging. If someone talks about a medium format camera, phase one is somewhere in that discussion. But it goes beyond just the sensor of the medium format, but upon a component, a system, or even a solution using that. And that could be in a wide different areas, which I hope we'll walk away with knowing where those strengths are in those particular areas, even down to the medium format sensor. From a company standpoint, phase one is headquartered in Copenhagen. It's one of our R&D centers really for the camera core technology. And there's two other R&D centers as well. The one in Israel is really the industrialized group, which is a lot of the technology or products that come from my group is through the Tel Aviv office or factory. But that's from the camera side. We also have an R&D center in Japan that is dedicated to shutters and lenses. So the combination of those three R&D centers makes an amazing product to deliver great results. But everybody needs a face, a point of contact outside of those R&D centers and those factories, and that's where we have offices spread across the globe, North America, Germany, and Hong Kong. In respects to the Americas, it is Broomfield, Colorado, just north of Denver. We also have a New York office as well. And it's not just the phase one face directly, but we also have quite a few integrators and partners. In fact, I know there's quite a few MAPPS members that own phase one technology via an integrated dual payload sensor or such, maybe from a LiDAR or so forth. So phase one began or started back in '93 for the professional photographer. And it wasn't until 2011, 2012 where our camera was taken from a professional photographer and put in an aircraft to take images with some few adjustments, of course. And since then, it went from that one camera to many different cameras, many different lenses, and now we've added third-party components on top of that to provide complete turnkey solutions and systems. Now, something that might be new to many of you that are watching this today is we do have a ground division. We've always had one. It's becoming more robust because of the breadth of products and cross-utilizing some of the existing products in different use cases and applications. So as part of the overview on the aerial side, which I'll go through in some detail, we're going to touch some on the ground side and specifically from a mobile mapping standpoint. I got a couple of tests that we've done that I'll share with you and some other use cases where our products are in use for mobile mapping systems. And not to minimize the fact that we look like a hardware company with the cameras, but the glue that holds all that together and helps maintain that workflow is that software. And so we do have software products on the image enhancement side, on that planning side, and acquisition or capturing side as well. So out of all the product lines that phase one has to offer in the different business group, the aerial industrial is probably the one with the most breadth and depth. And that's why we're going to go through some of these specifics to understand when do I use this camera or when do I use that camera and why would I do that. The top portion of this slide, I know it's a little busy, shows the graduation from the 150, which has its place, the IXM 50 megapixel camera, all the way up to the 280 megapixel camera. The below portion of this screen really shows the history or evolution. That one IXA camera that we first released in 2012 through 2018, and now our most recent announcement in 2020 is the 280 megapixel. What does this mean for you as a potential end user or an integrator? It gives you a technical edge. It gives you the ability to select a tool, a kit, or a system to give you that edge for that specific use case or application, or maybe it's a range of applications. Whether it's a 50 megapixel for UAV type mapping, or up to 280 megapixel for wide area mapping, or even yet combining the 280 with some oblique cameras to do digital twinnings of cities and or other civil infrastructures. The medium format sensor. You may have heard that term, maybe not know 100%. What does that exactly mean? Well, in comparison to other cameras on the market, 35 millimeter DSLR, medium format is 2.5 times larger. There's two things that equate to that. Some more obvious, maybe some not so obvious. Number one, a larger sensor gives you a larger footprint per frame or per image, which gives you fewer frames, fewer flight lines, reduced project time, so that increases your efficiency. Another benefactor for the phase 1 medium format is the high dynamic range. What does that mean? Well, that means that I get less impact or less noise from a high contrast environment. What comes to mind when I think of that particular scenario, and there's many scenarios, there was a project for an environmental agency that was doing mammal counting, seals to be specific. So you had these seals on these ice caps that were bright white around this dark water, and be able to get good quality imagery from a very high altitude that doesn't scare them, so they can be counted through AI or other intervention means. But even probably more applicable to this group today, it's being able to capture imagery in a wider range of the day when there might be shadows, but still getting the quality of the data in those shadows when you have a sensor like phase 1's medium format with a high dynamic range. There are really two cameras that are the core, the bread and butter, so to speak, of the phase 1 camera line today. It is the IXM and the IXM RS. These cameras were released 2 years ago. The IXM is specific for, was designed initially for UAV or UAS use. But we find that now more transitioning from the ground or anything from the ground up to 400 feet, which is the current UAS ceiling unless you get waivers. The IXM fits very well in that range. It was designed with having the ability to withstand some inclement weather, dust, a little bit of rain, being lighter weight compared to the other cameras, and also having the back display screen was removed in its predecessor, so you see the back of the camera here. You can add heating or cooling depending on the operational temperature this camera might be involved with, and that's really important because we do have clients that do operate outside of the temperatures that this was designed to run in. The IXM-RS is going to be your standard camera that you'll see in manned aircraft, which many of you may own today, or its predecessor, the IXU 1000, was its predecessor as another similar 100 megapixel camera that's in use. That weighs a little bit more, but weight typically isn't a factor in a manned aircraft compared to the UAS or UAV. Now, to go even a little deeper into the IXM series and the sensor that's being used, it's backside illuminated. Maybe you've heard that terminology before. What does that mean? Well, if you think about the same area or footprint with the higher resolution, so I'm increasing the pixels within the same area, what does that relate to? It relates to a smaller pixel size. And at some point when you get so small of a pixel, less light gets to that pixel, and thus it increases your noise level and your high dynamic range. So how does that get worked out? How do we work around less light getting to that pixel? Well, it's changing the architecture or the structure of the chip itself. So the chip manufacturer for the 150 megapixel and the 100 megapixel, the IXM, because of that 3.76 microns, change the wiring structure to be behind the photodiode so more light gets to that smaller pixel. Now, does that make the front side illuminated sensors inferior? No, because they're a larger pixel size. If you see on the far left, the IXMRS 100 camera, the IXM50 camera are front side illuminated CMOS sensors, but their pixel size is 4.6 microns. So your dynamic range is at 84 dB, where your backside illuminated sensor is at 83 dB. So very little compromise the integrity by going to a backside illuminated with a higher resolution count within the same frame. I realize that this may go a little deeper, but it helps you understand the value behind the sensor and what it brings today with these current camera lines. Now, a common conversation or question that comes up is about forward motion compensation. Do your cameras have forward motion compensation? Well, in a sense, yes, they do. It's better than that. We call that the blur control technique. And that takes into account two things. One, the high dynamic range we talked about, and two, the fast shutter speed as well. The combination of those two allow to mitigate or minimize any blur and still have high quality imagery. So to give you some perspective or some idea, I have a table here on this particular slide that based on a 5 centimeter GSD and whatever exposure time that you would set for your camera, what type of speed would incur some type of pixel blur. So you'll see motion blur at 1 pixel and 2 pixel. Typically the quality of that mapping data is not compromised under a 2 pixel blur. So speeds, if you were 1/2000 shutter speed, traveling 194 knots with 1 pixel blur, you wouldn't see that. You could travel up to 389 knots and have that mitigated and not be an impact or negatively for your deliverable. So that's kind of helps a little bit more on the blurring side or what can be expected. The IXMRS series, this is the same information that you'll find on our website, but just a couple of highlights. Number one, why would I want a 100 megapixel camera when you're selling, you offer a 150? Well, it comes down to use case. If you have projects where maybe the colorization of the point cloud is quite sufficient with 100 megapixel, there's no need to go to 150. That being said, out of the two cameras, the 150 is the top selling camera today between those two. Now, it does have the ability to synchronize up to 6 cameras within 50 microseconds of a synchronization or a trigger. And that's key when you're doing digital twinning or multi-camera arrays to getting a wider swath or whatever your intentions are. It says the data storage has an XQD card. Quite frankly, that XQD card is not as used so much in a fixed man or a fixed man aerial type application. That is typically more used for the UAS, the unmanned systems, whereas we use a computer controller, the IX controller Mark IV specifically, to be used with the IXMRS cameras. But you can use a card if you choose to. Now, this is a chart with the lenses that we offer. In fact, we're 2 more to add to this. We have a 23 millimeter and a 28 millimeter to add to this whole slew of lenses that are available for the IXMRS camera, 100 or the 150. The reality is that if you narrow down the use cases for corridor mapping or what have you, typically it's a 50 millimeter or 70 millimeter lens. Yes, there are use cases to use the whole breadth of these focal lengths. That's why we offer them. But when it comes to corridor mapping specific, it's the 40, 50, or 70 typically are the ranges. And that depends on your deliverable for GSD and swath, or matching the swath of another sensor helps us decide of which particular one that is. So if you're ever confused or you say, which one do I go with? Please don't hesitate to contact one of the Phase 1 experts, and we can certainly step you through those exercises to get the right fit for the right project. So to give some perspective for those that may have not seen a phase 1 image, the one on the left is a full extent of a full frame from a 150. The image on the right is a zoomed into the right turn lane of that specific image. And I've got some more examples more from an inspection standpoint as well, but it kind of gives you the idea of how much area I can cover in one frame and still see a lot of detail on the ground. In 2016, we announced or released a 4-band solution. Essentially, that's 2 cameras, the RGB camera, with an achromatic camera beside it on a plate that has a filter specific for near infrared. So it's achromatic, which means it has a range of 350 to 1,000, but in this case, we are only looking at the light reflection at 720 to 1,000. And there's other bandpass filters that can be applied, but as a standard configuration, this is what to expect from our 4-band system. Now from that, phase 1 provides the workflow to take it to an RGB image, the near infrared image, or to create a 3-band stack, that's CIR, or even a 4-band stack, all 4 bands as well, or in DVI. This configuration is becoming a standard for most mapping systems today. And it's even gone one step beyond this particular configuration. When you talk to folks that are doing agricultural management, typically they're looking for unique signatures or reflections of either diseases, invasive weeds into crops and so forth. And this is more critical from an organic farmer that doesn't have the same mitigation tools for reducing this or minimizing the disease. And so identifying where those are and the intensity and the extent of it is really important. So with our high resolution cameras with multiple achromatics with specific bandpass filters, it can identify that. So this multispectral solution has been a very favorable solution from phase 1 for a lot of customers. Now, moving from a corridor mapping type use case or application or camera, moving to more of a wide area mapping. So we released the 280 megapixel camera this year. It is shipping today. The camera, if you want to integrate the camera to an existing system, it's on the shelf and ready to go. We've finally caught up with the demand. So you're about a 10-day delivery on the camera. For the systems, because the systems involve your choice of a stabilized mount, a GNSS IMU, our delivery time is closer to 4 weeks as opposed to 10 days. But we can work something out if you need to. You'll see that the 280 megapixels is kind of funny looking. It's like 2 cameras pressed together. Well, I'm oversimplifying that it's 2 cameras pushed together because it's a little more complex than that. Inside the camera itself, those 2 sensors are offset just a little bit from the center of the optics or the lens. What that gives you then, when the camera is nadir, facing straight down, it gives you that 20,000 plus pixel cross track with just a little bit of overlap. And it's something that you don't have to worry about getting those images stitched together, because part of the workflow from phase 1 is to stitch those images together so you get that 280 megapixel image through the workflow process using IX capture. Just a snapshot of what does this do at higher AGL, 10,000 feet, 5-inch GSD, traveling at 200 knots. You have a cross track of 8,400 feet, a long track of 5,898 feet with this particular setup. Now the 280 megapixel camera has a fixed focal length of 90 millimeter. This is unique because our 150 are single sensor cameras. You obviously saw the choice of different lenses from 23 to 300 millimeters, but specifically for the 280, because it's designed for that wide area mapping, it's fixed to the 90 millimeter lens. So wow, you talk about manned aircraft options with different sensors. What's the right one for me? Well, for corridor work, oversimplified, the 100 megapixel is a good solution. The 150 megapixel is a good solution. And again, in that range of 40 to 70 millimeter lenses are good matches for the right camera for that type of work. When we talk about wide area compatibility, The 1900 was the camera from us for wide area solution, but now for a wide area format, we have the IXMRS 280, which has a 20,000 pixel cross track. Now, what makes this a good tool, even though there are other camera systems on the market that may have a much wider cross track or a little bit wider cross track, is because of the speed at which you can collect the imagery. It still makes it a more efficient camera to use in the marketplace. Okay, I'm going to switch gears. We're going to go lower elevation, lower AGL, 400 feet and under is the IXM series camera, the IXM 100 and the IXM 50. We released these cameras 2 years ago in 2018, and the IXM 50 was a hot ticket. Everybody wanted the 50 megapixel because at 400 feet, nadir mapping, that did blow away any type of requirements that I needed. I could outdo any of my competitors, and I could capture and deliver some mapping products that were amazing. The 100 megapixel was by itself, didn't move a lot initially. Once these cameras got out to market to do mapping, they, service providers started realizing, well, if I put this at an oblique angle, I can start doing oblique inspections with it. Well, maybe 100 megapixel might be better. So we've seen a transition from the 50 megapixel being in hot demand to the IXM 100 or the 100 megapixel camera. 10 to 1 is what our sales are today when it comes to this particular configuration. Again, it has very similar. You can synchronize up to 6 cameras on a manned aircraft with this. When this is used in a manned aircraft, typically it's an oblique setup. And a lot of times this particular camera is used on helicopters as well. And I'll go into that a little bit later. In this case, the XQD card does become an important feature because there's no necessarily computer IX controller strapped onto the top of a bird. It's relying on the memory capability of the XQD card to save that imagery. The unique thing I would say about the IXM camera that it's different from others on the market, other than the resolution, the amazing results or details that you get from it, is in its operational phase, it captures 2 to 3 frames per second. That's consistently reliable 2 to 3 frames per second. It doesn't have a burst rate and then it has to wait to save. And this is critical if you're trying to do a mapping missions and you got waypoints every second to wait for that camera to catch up. Phase 1 is consistent and reliable on that frame rate. It doesn't drop frames. With the IXM series, we added the 10G Ethernet connection. I wouldn't say it's leveraged as much today, as I know integrators moving forward are starting to use that data exchange as opposed to the USB 3, but USB 3 has been the most common. All right, lenses for the IXM camera. I have a UAS. Which lens do I use? Well, from a mapping standpoint, the 35 millimeter and the 80 millimeter are the lenses of choice to use. Those are fixed to infinity focus. And those are the typical lenses for that process or for that type of application. The other 3, the 80 mil, the 150 mil, and the 300 mil are motorized lenses, and those are used for inspections. Now, a little trick, or might not be so clear in this slide, which it's by design, I think, is that the 300 mil lens is here in this image showing that, hey, this is one of your RSM lenses for the IXM 100, and it is. It works well, but not in a UAV. It's too heavy of big of a lens, so it's got to be a pretty beefy UAV to be able to support that. So the application for the 300 mil lens specifically that we've seen when it comes to 400 feet or in that range of 500 to 600 feet maybe, is on a helicopter pod with a stabilized mount with the IXM 100, or the IXMRS 150 will also match up to the RSM 300 lens and doing utility infrastructure inspections. That's the sweet spot for this particular lens when it comes to the IXM 100 camera. The 300 mil lens also has a sweet spot when it's flying super high for intelligence or defense type missions where it's needed to be very high to capture mapping data. So when it comes to IXM 50 or IXM 100, I just wanted to show a quick screenshot of what type of resolution you can expect on the ground. So for the IXM 50 with the 35 mil lens, you're about 1.85 centimeters at 400 feet AGL. And that one frame size represents 502 feet by 376 feet. And that's a typical mapping camera. Now, moving to the IXM100, which is more used for inspections, you're looking at, with the 80 mil lens, a 0.5 centimeter GSD at 400 feet, and your frame area is 219 to 165. And this has been very popular for a lot of the utility infrastructure inspections, but not limited to that, but it is popular for that as well. So to give you some use case information, bridge inspection specific, and by the way, this case study is on our website. This particular third party compared 3 different cameras, the DJI X5, the Sony A7R, and the IXM100. Each at different distances, well, actually different GSDs is what it was compared to. What it came out to be is that phase 1 of the IXM100 camera could be 49 meters away from the bridge and still capture the same resolution that the DJI camera was at 9 meters away from the bridge. So to look at the high resolution that this customer wanted to see on the inspection site, the last 3 rows, the DJI X5, the Sony A7R, and the IXM100. A part of the bridge inspection caveat is you can't be too close to the bridge with the UAV. And so right away, to get to that resolution with one of those 3 cameras, the DJI X5, it was in the red zone. You cannot use that bird, that camera that close to the bridge. When it comes up, everybody's toast, right? Even the Sony A7R was in the caution range. But with the phase 1 camera, 9 meters away was still considered that safe zone. And if you go to the lower right-hand corner, second column, the flight time was 2 minutes to capture that bridge at that resolution in comparison to the next camera, which was more than double the time that it took. So IXM100 cuts your efficiency in half and doubles your capacity to do more in one day, more with one set of batteries. All that comes in line with dealing with the UAS. Okay, real quick, I'm going to go through the ground side. Now this is kind of groundbreaking, excuse that terminology. It's relatively new. We started off with a partner that integrated 4 phase 1 cameras onto a car, and the purpose was telecommunication assets, was being able to see the ID tags in addition to other condition-related inspection items while driving in the car and capturing that from the road. And so the standard cameras that were on there, the 360 camera, was great from a situational awareness, but from an actual inspection standpoint was not sufficient. And so putting 4 phase 1 cameras on there did get the job done. Now compare that to how this telecommunication company inspected before, feet on the ground, 10 to 20 poles a day, versus driving a vehicle that had the high resolution cameras to get what that person was looking at and doing 150 field miles a day. Big difference. I just blew up that last picture in the previous slide just to get a better idea. And you'll get to see this coming up here in a couple more slides. To emphasize the high dynamic range, driving under bridge, it's dark under a bridge. It's typically not well lit. But because of the high dynamic range and the capture software that we have to be able to lighten it and see the details, really key and critical for inspection. So there was a test that we did a year ago with the new lens, the RS23 millimeter. Has to do with the blur and smearing while driving. How fast can I go? How far away is that target can I be to get good quality imagery? So in short, we took pictures of it while the car was stopped. That's what you see in the top image, that 97. The car's not moving. But if you look below that second set of images, you'll see that it was driving at 22 miles per hour using this IXM RS100 with a 23 millimeter lens. You can still see the quality of that number. And when you look at the extent of that frame to the right, you can't even make sense of it. But by zooming in, there's no blur there. It can be easily identified. Now, doubling the distance from 26 to 50 feet, you'll see the results. We stopped, took an image, and then we drove by. And while the car was moving, we took an image at 22 miles an hour. Still very clear to see the details of the address number. So let's push a little more. Let's go a little faster, do things that are a little further away. In this case, the security camera was 66 feet away at 34 miles an hour. There is introduction I can see in this particular image of blur, and that may require additional enhancements to improve that. And last, driving 45 and 34 miles per hour, 66 feet away was the target. You can't even make sense of what that is in the extent of the picture, but zoomed in, you can still see the details. And if you're well-versed in different languages, you could read that very clearly. But regardless, you can still make use of those characters. So phase one offers quite a breadth of different products and depth of them with the lenses. Which one do I choose? Well, to narrow it down, aerial corridor work, IXMRS 100 or the 150, or one of our turnkey systems, the PAS 100 and 150, with one of 3 or 4 lenses, 40, 50, 70, or 90. When it comes to wide area mapping, IXU 1900, IXMRS 280 camera, or the PAS system 190 and 280. And I know that our partners offer some of these solutions as well with their payload as well. From a UAS mapping standpoint, IXM 50 with the 35 mil lens, that's the right solution for UAS mapping. For inspection, that's going to be the 100 megapixel with the 80 mil lens is the most common. But remember, there's a 150 option as well. From a mobile mapping inspection, the IXM 100 with the 23 mil lens, because it has a wide field of view within that frame and still being able to see a lot of detail within that 60 to 70 foot off-road distance, but could be considered even more with different lenses, just a narrower field of view. So I want to thank you guys. Thank you for pushing through the Zoom fatigue, following along with the details and the breadth of what phase one has to offer when it comes to high resolution cameras and medium format technology.
Thank you very much, Dana. Very informative. Appreciate that. Question for you. Phase one continually comes out with new cameras, new things, new whatever. How quick does your client base turn over cameras? How quick do they update or upgrade, I should say?
Well, typically it's 3 years.
Okay.
Yep.
Here's a question. Does phase one intend to develop a spherical camera array or work with existing manufacturers to integrate your cameras into their spherical array solutions?
Always open for those discussions, yes.
All right, I don't see any.
Excellent.
Dana,
Well,
thank you very much.
Thank you, Mark. Appreciate it.
Appreciate your continued support of MAPPS. We look forward to hearing you in the future.